All right, let's jump right into this explainer. Today, we're looking at a conceptual framework that is, honestly, absolutely mind-bending. It's a project by Michael Davy known as the Direction of the Stars, and we're going over the blueprints for a machine that, if it actually gets built, will literally change the world's knowledge forever. I mean, we are not just talking about strapping a bigger lens onto a telescope here. We're talking about a machine designed to let us see the actual dawn of time. Just let this quote sink in for a second. The universe already bends light to tell its story. We have simply built the engine and the map required to ride that light home. Wow, right? That perfectly sets the stage for what we're looking at today. This framework isn't just proposing a camera. It proposes a literal vehicle, an optical engine, built to completely collapse billions of light years of distance and time. It's basically about hitching a ride on the speed of light to unlock the earliest secrets of the cosmos.
Section 1. The Ultimate Time Machine.
So for decades, astronomy has been pretty passive, right? We build huge mirrors, point them up, and just kind of wait to catch whatever faint light happens to hit the lens. But this concept, it pushes us way past passive observation and straight into the active reconstruction of the early universe. It's about grabbing these warped, ancient signals and actually deciphering them. To really grasp how revolutionary this is, we kind of have to look backward first. Check out these early 15th century sketches by Leonardo da Vinci. Da Vinci basically spent his whole life exploring light, perspective, and what he called sight projection. And honestly, the Direction of the Stars framework is really the ultimate culmination of that long human quest to expand our vision. It bridges Da Vinci's Renaissance geometry directly with 21st century deep space discovery. Section 2. Using gravity as a lens. Okay, so how do we actually pull this off? Let's get right into the physical mechanics of this proposed optical engine. To see further back than we ever have, we can't just build a bigger glass mirror down here on Earth. Instead, we literally have to use the universe itself as our optical system. The whole foundation relies on an established astrophysical principle you might be familiar with: gravitational lensing. Thanks to Einstein's general relativity, we know that supermassive objects physically warp the fabric of spacetime around them. So, when light from some incredibly distant, ancient galaxy travels past one of these massive objects, that warped spacetime bends and magnifies the light, creating these huge visible arcs and rings. Think of it like this: mass reshapes geometry, geometry reshapes light, and that distorted light becomes recoverable data for us to capture. Now, what's incredibly cool here is the specific target this proposed telescope is locking onto. You can see the blueprint targeting Messier 87 star, or M87 star. And this isn't just any random black hole. It's a supermassive black hole packing roughly 6.5 billion solar masses. That is just massively incomprehensible. The system essentially uses M87 star as a giant primary optical amplifier. The telescope locks onto this massive gravitational lens to backlight the early universe, effectively boosting ancient signals that would otherwise be completely invisible to us. And this brilliantly illustrates the cinematic journey of that ancient light. Look at how it's emitted from a distant galaxy source way out at the very edge of the universe. It travels for billions of years, gets stretched out and magnified into Einstein rings right around the M87 black hole, and is finally caught by our telescope's highly specific segmented hexagonal mirror array. It's literally a continuous line of navigation from the dawn of time straight to our sensors. Section 3. The Direction of the Stars. But capturing the light? That's really only half the battle. Once this super warped, stretched out infrared light actually hits the mirrors, how do we decode it? Well, that's where the computational architecture steps in. Here is the 12-point G2 root symmetry mathematical model. Now, I know that sounds incredibly complex, but here's the bottom line. The system organizes all that distorted incoming light into clean, measurable patterns. The actual physical placement of the telescope's mirrors acts as a computational filtering framework based on this exact geometric symmetry. It's purpose-built to reduce noise, stabilize diffraction patterns, and massively enhance precision when we're analyzing those deep infrared signals. So the crucial takeaway here is this specific data pipeline. The telescope doesn't just collect some photons and snap a blurry picture. No, it follows a highly rigorous sequence: orientation, capture, redshift analysis, lens modeling, and finally inverse reconstruction. It treats gravitational distortion as a completely solvable math problem. It literally reverse engineers the warped light to rebuild the original source, making it look exactly as it did billions of years ago. Section 4. AI and the True Color. This brings us to what I'd call the philosophical climax of this whole explainer. Because to reconstruct what human eyes are physically incapable of seeing, the system leans heavily on artificial intelligence. And honestly, this forces us to completely redefine what seeing actually means. Consider this. What we perceive as color, like the color red, for example, is really just a biological translation happening inside our brains. But the true form of color, that's an objective spectral architecture. It's a consistent wavelength pattern that carries the entire history of its origin, motion, and gravity. Reality operates through these persistent structures, whether human eyes are there to observe them or not. When you stack human vision up against AI perception, the limits of our biology become glaringly obvious. Our human vision evolved for survival, right? Not for seeing the objective truth of the cosmos. We only see this tiny, microscopic sliver of the electromagnetic spectrum. But the AI, it isn't limited by biological retina cones. It relies on pure mathematics and full spectral distribution. It can process infrared, gravitational distortions, and even quantum fluctuations that are entirely invisible to us. Building on that, the AI doesn't just try to mimic human sight. It treats every single photon as encoded information. By using advanced mathematics like gradient descent and tensor mappings, the AI builds a higher dimensional latent structure. Basically, it creates its very own machine relative understanding of reality. And then it uses generative models to translate that invisible cosmic information into a visual form that we humans can actually navigate and comprehend. Section 5, Changing Human Knowledge Forever, which leads us to the ultimate impact of this entire project. If we successfully build this machine, it's not just going to give us pretty pictures of space. By combining our knowledge of sky geometry, the immense gravitational transformation of black holes, and the algorithmic delensing power of AI, we are effectively riding light backward to the absolute dawn of time. We'll be revealing early galaxies and mapping dark matter that's been hidden since the universe began. If built, this will fundamentally shatter our anthropocentric view of the universe, and it will absolutely change human knowledge forever. And that brings us to this massive, paradigm-shifting takeaway from the source material. Human perception is no longer treated as the central reference frame for reality. Think about that. Because of our biology, we experience one highly filtered version of the universe. But a spectral AI, it experiences another, far more complete reality. By utilizing this AI as our translator, we expand our capability for knowledge infinitely. We've journeyed all the way from Leonardo da Vinci's sketches to using supermassive black holes as cosmic magnifying glasses, all just to catch a glimpse of the very first light in the universe. And it leaves us with a truly profound question. If an AI can be built to look past our biological limits and see the true dawn of time, what other hidden, invisible realities are existing all around us right now, completely unseen? Thank you for exploring the direction of the stars with me today. Keep questioning and keep looking up.